Good afternoon, I am Mr. Ish. We're looking here at conic section parabolas in a generalized sense. If you take a three-dimensional cone and you slice it in a particular manner, you can generate what are called parabolas. You know the quadratic parabolas. Well, conic section parabolas are exactly the same thing, but you're looking at the same thing but in a different perspective. You have two equations you need to be worried about. X squared is equal to 4py, which is the shape of an parabola angled upwards with a vertex here at the origin, and then y squared is equal to 4px, a parabola which is of course vertex at the origin but angled towards the right. If you're looking at x squared is equal to 4py, then this right here, the exact reflection of it is what you know to be minus 4py. Of course it will equal x squared, and this one right here, if you're looking at a parabola which is reflected in the other direction, that'll be minus 4px. But in all instances, these are the four equations, this one right here, this one, and then here of course y squared is equal to and x squared is equal to minus 4py and minus 4px. These are the parabolas you need to be aware of. When you're looking at parabola questions, there are varieties of elements that come about, and you need to know what those elements are, which are basically the anatomy of the parabola, the parts of the parabola. We should only be focusing here in the general sense on the positive aspects. When you're looking at x squared is equal to 4py, you have, and we don't need to talk about what a parabola is, you can learn that on your own. You're looking here in terms of test preparation, what are the elements. You have over here for this specific one, a vertex here is a 0, 0, which is at the origin. There's a specific focal point which develops. Alright, the focal point over here, let's abbreviate it, is 0, p. It's directed upwards. There's a specific directrix, which is a line which is equal distance away from the vertex as is the focal point. What are this distances? You have a directrix which will develop right here, and the directrix for this type of parabola directed upwards is going to be y is equal to minus, you can say minus p. Your p units away from your vertex up for the focal point, your p units down from your vertex to your directrix. So this right here is my focal point. There's a specific line or segment you can draw through the focal point from one side of the curve to the other side, and that's called the latus rectum. Latus rectum. It's a chord which goes from one side to the other side. It has the coordinates, as you can imagine over here, would be minus x comma this value right here, the focal point y value, which would be p, and then you'll have positive x comma p right here. See, positive x comma p, minus x comma p. These are the things you should be able to decipher from a parabola. Of course it has a line of axis, a line of symmetry, which happens to be here the y-axis. But these are all parabolas which are directed about the origin and which haven't been translated. Then of course you have to worry about the translations, but we won't worry about that in this particular video. We're just looking here at generalized sense. When you're looking at this rightward parabola, you're looking at a parabola which looks like this. And remember, these type of parabolas are not functions, because if you draw a vertical line it crosses at 2 points. These type of parabolas pointing up or down are functions. The ones which point right and left are not. Anyhow, here for this vertex is again 0, 0. You have a focal point which will be right here, but the focal point over here is going to be p units away, right? P units, so it's going to be p, 0. You have a specific directrix, an imaginary line, which I will abbreviate as d. Directrix, I'll abbreviate that as a d. And here it happens to be x is equal to minus p, because your p units from the other side of that vertex. You have a latus rectum. Remember, latus rectum is a chord which goes from one side of the curve to the other side, but going through this focal point. This latus rectum here would have coordinates. What will be the endpoints here of this latus rectum? That and that. Well, you know, if this right here is p, 0, it'll have the same x-axis value as the focal point, right? It'll be p, y, and then here it'll be p, minus y. P, positive y, p, minus y. And you know you have a line of axis. The line of axis here is your x-axis. So let's look at two questions and see if we can decipher all of this. It's not hard. You just have to get used to doing it. Let's look at two questions, and let the first question be this. X squared is equal to 20y. And this right here is our representative equation for a parabola that points upwards. If it was a negative or parabola going down, you would have a negative here, but we don't. We're keeping this simple and to the point. You have to convert this specific part into a 4 and a p, because you must get that 4 and p, and you can do so. X squared is equal to 4 times 5 times y. Now I know my p value is a 5. I know I'm looking at a vertex here at a 0, 0, because this is always the case here for a vertex directed from the origin, 0, 0, and it must be pointing upwards. I know my p value is 5. Within the U, within the bowl or the curve of the parabola is always your focal point. But it's p units away. You must look p units up, you must look p units down. When you look p units up, you have your focal point. When you look p units down, you have your directrix. The focal point is p units away from the origin, 0, 0, but its movement here along the y-axis, so it'll be 0, 5. Think about it, you moved up 5 units along the y-axis dimension from 0, 0 to 0, 5, and my 5 is coming here from the p. My directrix is a horizontal line. Up and down parabolas have a horizontal line directrix. Here it must be y is equal to minus 5 because you moved minus 5 down. Remember, the vertex falls directly between the focal point and the directrix. Now let's look at the lattice rectum, which is a chord going from one side of the curve to the other, but through that specific focal point. How do you determine the lattice rectum points, the endpoints, this one endpoint and this other endpoint? Well, you take this equation right over here and you have to solve for x, but what do you put in place of y? You put exactly that value, which would be the y value of your focal point. The focal point is 0, 5, right? It must have the same y value as the focal point, because that is what the lattice rectum is. It goes from one side to the other side, but through the focal point. It must be 5. So x squared is equal to 100, and then x is equal to plus and minus 10. You must look at all the values, plus and minus 10, because if you do plus and minus 10 squared, you still get 100. Your points of the lattice rectum are minus 10, 5 and positive 10, 5. Minus 10, 5 and positive 10, 5. And lastly, line of axis or line of symmetry. Here is your y-axis, which would be x equals 0. These are all the elements you need to look for a parabola, whether it's translated, whether it is not, whether it's up or whether it's down. You must look for the focal point, you must calculate the p value, you must look for the directrix, the lattice rectum, and the line of symmetry. And there it is. Everything has been deciphered from this equation. Let's look at in the next question at the other form of the parabola, and then we'll call it for this video. Normally the question would be, you're looking at an equation and you have to analyze it. The question would be, analyze this. When you're looking at something like this, you're thinking about a parabola that faces and it's directed towards the right, because it's positive. There's no negative, otherwise it'd be facing towards the left anyhow. When you're looking like this, an equation like this, there's no translation. The vertex here is 0, 0. You must now break this into this form right here. You got a 4 times a 4. So that tells you automatically your p value here is equal to a 4. And remember, the focal point is always located within the curve, within and inside the curve. Therefore, your focal point must be right here. You're going to be p units in this direction for your focal point and p units in this direction from your vertex for your directrix. Your focal point here is very easily 4, 0. Your directrix here is x equals minus 4. X equals minus 4. Now you must determine the lattice rectum points. The lattice rectum is a chord which goes from one side to the other side, but through the focal point. How do you know what value to put over here in terms of your equation here? Remember, when you're determining the lattice rectum, you're always solving for the squared component. In the previous equation, we were solving for the x squared. Here you're solving for the y squared. You always put that value of the focal point. For the right-sided or the left-sided, you put in the x-axis value. For an up and down parabola, you put in the y value. What's the x-axis value here? It's 4, 0, right? Because my p value is 4, you put a 4 right in here. Y squared is equal to 16 times 4. Y squared is equal to 64, and therefore y is equal to plus and minus 8. Now you have to write your lattice rectum in the proper way. This is giving you a plus and minus your y coordinates, but the x coordinate is the same in both. It'll be 4, minus 8, which is this point right here, and the other one is 4, 8, which is this point right here. And lastly, your line of axis or line of symmetry, LOS, right here is your x-axis, which is y equals 0. And now you've seen we've analyzed this. Remember, vertex, the p value, the focal point, the directrix, the lattice rectum, and the line of axis all must be analyzed from your equation. Before I end, let me just show you very quickly. Everything we're looking here is a parabolas, or the parabolas in a standard form. What is equation of a parabola which is not in the standard form? You must know that, but that is beyond the scope of this particular video. Look what happens here. X squared is equal to 4py for a parabola that's directed upwards. X minus h whole square is equal to 4p into y minus k. Now you have a vertex here which is h comma k, and everything will adjust accordingly. This is no longer a parabola pointing upwards from the origin. It has been shifted. Check this out. Y squared is equal to 4px. modified y minus k whole square is equal to 4p into x minus h. It is a right facing parabola, but it no longer has a vertex at the origin. Vertex here is h comma k. It has shifted. All of these things come into play with any of the conic sections, whether they're parabolas, hyperbolas, ellipses, circles, all of that. You have this type of basic equation form from which then you derive everything else. But that makes things a little complicated. Here in this video we're looking at the standard forms only. And even then we're looking at the positive forms only, not even the negative. But let's end the video with that statement. Thank you for watching. Have a nice day.